Alright, 5.5, multiplying complex numbers. Objective, students will be able to find the product of two complex numbers. Let's start with just multiplying complex numbers by real numbers. Let's go to example 1. We're just going to distribute here. Remember, these are not like terms, but we could still distribute. So 8 times 11, that's 88. And 11 times negative 7, that's negative 77i. So that's it. All there is to it. Go ahead and give practice 1 a shot. Pause the video, and then unpause it when you're ready to check your work. Alright, 13 times negative 7, that's negative 91. 13 times 9i, that's 117i. There we go. That's pretty easy. Now let's go to something a little bit more fun. What happens if we're multiplying a complex number by an imaginary number? And we're still going to distribute, but something interesting is going to happen here. So 5 times, or negative 5i times 4 is negative 20i. That's pretty easy. But what's negative 5 times negative 2, especially if it's negative 5i times negative 2i? Well, negative 5 times negative 2 is positive 10. And then I times I is I squared. Well, remember, we learned something about I squared. I squared is really negative 1, so this is really like saying negative 20i plus 10 times negative 1. And let's switch the order because we like to have the real in the front. So negative 1 times 10 is negative 10 minus 20i. And there we have the complex product. All right, let's go to the next one. On practice number 2, you're going to do the same thing. Pause the video, give it a shot, and then unpause it when you're ready to check your work. All right, 3 times negative 7 makes negative 21, and there's an I there. And 3 times 9 is 27, but I times I is I squared. I squared is really negative 1, so we're going to move that real number to the front. Negative 27 minus 21i. Okay, getting real interesting here. Now we're going to multiply complex numbers by complex numbers. And this is very similar to just multiplying a binomial times a binomial, so I'm going to do the box method. So this is just like saying 2, negative 3i. So let's just go ahead and go through it. 2 times 7 is 14. 2 times negative I is negative 2i. Negative 3i times 7 is negative 21i. And negative 3i times negative I, the negative times the negative makes positive 3, and the I times I makes I squared. Now it's up to you what you want to do here, because maybe you want to write it all out, and we can do that. So we got a 14. We could go ahead and combine these. These are like terms. You have a negative 21 and a negative 2. That makes negative 23i. But this last one is worth thinking about here. Isn't I squared really negative 1? So this is really like 3 times negative 1, or negative 3. And so 14 minus 3 is actually 11. So the real answer here is 11 minus 23 minus I. There you go. So remember, this little I squared is negative 1, so that's where I got this negative 3. Okay, pretty fun, right? Why don't you guys give practice number 3 a shot. Remember to unpause the video when you're ready to check your work. Okay, so we're going to multiply these two binomials together. We're going to do box method. Just go through the box. 11 times negative 7 is negative 77. 11 times 9i is 99i. 15i times negative 7 is negative 105i. And 15i times 9i is 135i squared. I squared is really negative 1, so this is really just negative 135. Combine these two, you get negative 212. Combine these two, you get negative 6i. And there's your product of these two complex numbers. All right. Let's go ahead and jump to example 4. This is actually a word problem. This is where imaginary numbers are actually relevant in the real world. That's in electronics. So it says in an AC circuit, the voltage E, current I, and impedance Z, so we know what the E, I, and Z are related by the formula E equals I times Z. I think that's going to be important. Find the voltage, remember voltage is E, in a circuit with a current of 1 plus 3I amps and an impedance of 7 minus 5I ohms. So remember that E equals I times Z. E is what they're trying to get us to find. I is the current, and the current here they say is 1 plus 3I. So 1 plus 3I. Z they tell us right here is the impedance, and the impedance in this problem is 7 minus 5i, so I'm just going to do 7 minus 5i. So this is just multiplying. That's all this is. So let's use the box method. I got a 1 and a 3i. Let's go for it. 1 times 7 is 7. 1 times negative 5i is just negative 5i. 3i times 7 is 21i. And negative 5i times 3i is negative 15i squared. But let's talk about this part real quick. Remember that I squared is really negative 1. So this is really like saying negative 1 times negative 15. So this is really like saying positive 15. Important that you see that. So E equals 7 and 15 makes 22. 21 and negative 5 make 16, so I'm going to say positive 16i. And remember that E is really the voltage, so we're just going to say volts. Boom. All right. Pretty cool. Here we go. Summary. After seeing a couple problems that involve multiplying with complex numbers, you've seen a lot of problems with complex numbers though now. What are 1 or 2 things that you think will be really important to remember when performing these operations yourself? Think about things that I always checked for, I always did throughout the notes. What do you think is going to be really important? All right. See you guys in the next video.